So actually, this angle here, this is the 5 pi over 3, right? So now, we find the fourth spatial solution to this equation. And then we need to get another solution, okay, that is this angle, right? Because for this angle, the y-coordinate of the terminal side is also equal to the negative root of 3 over 2. How do we get this angle? So you may use the pi minus this fourth spatial solution, pi minus this s. So that is a pi minus negative pi over 3 to get the second spatial solution, which is between the 0 and 2 pi. So this is the 4 pi over 3. So now let me mark this out. So actually, this guy is the 4 pi over 3, right? So this angle is the pi over 3, and then this is pi. So pi plus the pi over 3, you get the 4 pi over 3. And definitely, you can use the pi minus the fourth spatial solution to get this second spatial solution between the 0 and the 2 pi. So now, after you find these two spatial solutions, then we know any solution to this equation involving the sine function just default to this two spatial solution by a multiple of 2 pi, right? You can only find those angles with this or this as the terminal side. So if you have the angle with this as the terminal side, then that should be the 5 pi over 3 plus 2k pi. If your solution has this line as the terminal side, then it is the 4 pi over 3 plus 2k pi. So now we form the solution set. So solution set, big S. This is a set of x such that either x is equal to, let me write this first, 4 pi over 3 plus 2k pi, or you have the x equal to 5 pi, okay, another spatial solution, plus the multiple of 2 pi. And here k is an integer. So in this way, we find the solution set to this equation involving only sine function. Any question? So the steps to solve this equation is, first, you use the inverse function to find the first spatial solution. And then after you find the spatial solution, you use the pi minus s to find the second spatial solution. And then add the multiple of 2 pi to these two spatial solutions to form the general solution. Now let's look at another equation involving sine function. So let's look at the special case. Sine x is equal to 1. Okay. So first, let's use the inverse sine to find one spatial solution. So here the S, the spatial solution is the inverse sine of 1. What is the inverse sine of 1? Half pi, right? Half pi. And if you want to get another spatial solution, you may use the pi minus this s, right? And in this case is the pi minus the half pi. You still get half pi. So actually, you look at this unit circle, only one terminal point, okay, here, has the 1 as the y coordinate. So that means between the 0 and the 2 pi, you have only one angle for which the sine function is equal to 1. So in this case, we have only one special solution between the 0 and the 2 pi. And then we can form the general solution. So the big S, the set of solutions is equal to the set of the x, such that x is equal to half pi m plus 2k pi. Then we find all the solutions to this equation, sine x equal to 1. Any question? Now let's look at another special case. And we have the equation sine x equal to -1. So first, let's use the inverse function, inverse sine, to find the one special angle. So we have the inverse sine of -1 equal to what? Negative half pi, right? Negative half pi. Because the range of the inverse sine is between the negative half pi and half pi. And in this range, okay, only the negative half pi for which the sine is equal to -1. So now, since we have found the one special solution which is a negative number, but we prefer the positive solution, so we may add 2 pi to this solution to get the smallest positive solution, which is coterminal with this, okay, special solution. So we just add 2 pi to this negative half pi, and then we have the 3 pi over 2. And here, if you want to form another, okay, if you want to find another special solution, you may use the pi minus this fourth special solution. But you still get 3 pi over 2. Okay, so that means between the 0 and 2 pi, you have only one angle for which the sine is equal to -1. Actually, you look at this fig. Here, only this point, right? You have the y coordinate equal to -1. So here, this is the 0 and -1. Only this point. And the corresponding angle is the 3 pi over 2. So now, we find the special solution to this equation between the 0 and 2 pi, and then all the other solutions can be obtained by adding the multiple of 2 pi to this special solution. So the solution set is equal to the set of x, such that x is equal to 3 pi over 2 plus 2k pi. Any question? So now we have seen several examples about the trigonometric equation involving sine x. And if you generally have the sine x equal to a, but a its absolute value is bigger than 1, then in this case we don't have solution, because we know the absolute value of x must be less than or equal to 1, because the range of the sine function is between the -1 and 1, right? You cannot have the sine value whose, okay, absolute value is greater than 1. So in this case, no solution at all. Now let's look at the page 559, and let's look at the summary for solving the sine x equal to a. So when this a is between the -1 and 1, and a is not equal to 0, first, you use the inverse sine to find the fourth special solution. then if this S is positive, then you have the one spatial solution S and another spatial solution pi minus S, and then use these two spatial solutions and add the multiple of 2 pi to them to form the general solution. So this is the case when the S is positive. And let me draw the unit circle to illustrate this.